For anybody just joining us, we are working on AP multiple choice in groups. There's a bit of a competition going on. So right now they're working on number 48, quietly trying to submit, not about getting it right first, but about getting it right, period. We've already done number 47 in the back of our homework spiral. Now, even though it's not about getting it first, to some degree, I do need to put in a time limit. So I'm going to say 2 more minutes. So what would be? Maybe. Maybe not. It's B? Get in your homework spiral. You guys just handing out answers? One more minute. That's what they thought. Yep. One more group still needs to check in. 2 groups have gotten it wrong. 1 group got it right.
Hannah, take them off. You're going to pass out. She's saying she's busy. She's sitting down and she's busy.
All right, final call. What do you guys want? Yes. That's right. 2 groups got it right. Why is E the only one that must be false? It's a critical point, which means F prime is either 0 or can't be negative, doesn't make sense. Some of you might have gotten stuck on the strictly decreasing, but remember, strictly decreasing is over an interval. At a point, a momentary stop is not a problem. Most people thought that C was the right answer, but you forgot to consider a vertical tangent line where I could still be strictly decreasing. But the derivative would not could be true. All right, final answer. E. Okay, new person with the marker. This will be in the notes if you guys want to put it in your homework spiral later. Let's keep going. Any marks? Okay, you got it. You got it. Which of the following functions has exactly 2 local extrema on its domain? Nope. By hand only. Which of the following functions have exactly 2 local extrema on its entire domain? Hopefully, if time was running short, you guys know which one you would guess. Hopefully. I should give bonus for who gets this first, but... I'm waiting. Because someone saw your answer. I'm waiting. I'm waiting to give my final call. I'm waiting to give my final call.
You like almost missed my hand. Hannah, it's not that big. Who saw our answer? Yes, I was. No, but she said saw, not heard.
You all got it right.
Yes. It was on the homework. It was on the homework, right? Yeah.
Pause! Why is it the only one that makes sense? You know what he looks like? He only has one. That one's derivative. You know what the function looks like. This one, take the derivative. He only has one possible critical number in the domain, so it couldn't be 2. That one, his zeros are imaginary. He's the only one that even possibly makes sense. Good. Everybody got that one. We have a 3-way tie. But now everybody has points. All right, next one.
Wait, who's in the tie?
Groups 1, 2, and 3. 1, 2, 3. All right, final answer, letter B. One more from section 5.1. All right, new person with a marker? Hold on, that's not going to work. Let me scroll up. If an even function, this is a party. If an even function f with domain all real numbers has a local max at x equals a, then f of negative a equals. Homework spiral.
Oh, wait, so we're tied? So we ended with a tie?
We have one more page.
Oh.
30 more seconds. You have the answer? Let me see. Let me see. Yeah. Okay, everybody got it. We have one more page. Okay, you ready? Final answer was local max because symmetry. F of negative x equals f of x. So f of negative a will be the same height as a. Therefore, yes, it does have to be a local max. All right, ready? Last multiple choice. Last page of multiple choice. New person? If f of x equals cosine of x, then the mean value theorem guarantees somewhere between 0 and pi over 3, f prime is equal to what?
Hey, no, man. No, but yeah, I'm looking at the board. Wait, what song? What song is this? Okay, wait. Look on her face. What?
sounds like.
Wait, Misty, was that a nod or a shake? I'm confused. I know, but she didn't say
Can you give it to James?
James.
I didn't say it was wrong. I wasn't saying he was
It's a.
Did she ever get him wrong?
Wait, are we ready?
You got it right. I don't know if I agree with your work entirely, but you both got to the right answer.
I trust you, but I don't know what's going on. Okay. Okay, good.
Wait, so you guys are right too?
Yes, okay. Okay. I think I did. I think I know what you're doing. Yeah, right?
Look how far it goes.
Okay, right?
30 more seconds.
Yeah, that's okay. You're good, you're good. You're good. I know, I was just thinking of me. I got finished 2 seconds ago.
Final answer, A.
That was my fault. I'm really sorry.
You guys had it switched for some reason.
We had a what?
You had it switched for some reason. It turned out okay, though. You would do latter minus former.
Oh, it doesn't matter though, because if we keep them matched up, then the
Yeah, it was all right.
yeah, it's a
All right, number next one. On what interval is e to the x cubed minus 6x squared plus 8 decreasing? E to the x cubed minus 6x squared plus 8 is the function you're dealing with.
Everyone got that test. This is the test of the national wires and registers.
Yeah, third, fourth period.
Oh, it's 11:18.
Okay, so we have to find out what this is. I know, but we have to start with equals to find out the distance. Wait, no, because it's horizontal. Horizontal asymptote, so we're we don't need that one. Who needs all that noise? Oh, you guys are so smart.
Nobody yet, huh? Get it in your homework spirals if your group got it. Get it in your homework spirals. Thirty seconds.
Oh, baby. That was the closest we could get. Yeah.
3x squared minus 12x times e to the bleh. What's true about e to the bleh? What is it always? Oh, the derivative is, yeah, true, but e to the, what's true about the sign? Always, always positive. So then you ended up being able to pull out a 3x and getting an x minus 4. Your critical numbers were 0 and 4. When you plugged in correctly, you should have gotten them one interval and one interval only, where the function was decreasing, the first derivative was negative. Second to last one. Which of the following is an antiderivative of? Ooh. New person marker. Oh, here. Sally, we should just bring this chair back.
Wait, how do you get this?
There you go. Okay. There you go.
Oh, I think I don't.
Oh, I guess that doesn't, well, it depends on who has the board, huh? They'll double check with you.
Actually, it's
Alright, well, at least we won't be like last week for last.
I'm so sorry.
You guys went too fast. Take the derivative, you'll see it. Okay, get it down your spirals if you got it right. Four. First place, groups 1 and 3 are tied on the last problem. As we go into it, groups 2 and 4 are tied. We have 6 points with this group up here and that group back there, and then we have 5 points with that group and that group. Okay, you ready? Well, they were originally sitting there. It got confusing, so it was 1, 2, 3, 4, and then 1 moved up there. This is x to the negative 1/2, which means the antiderivative is x to the plus 1 times the reciprocal. Bring down the 1/2, the 2's reduce. There you go. All right, last one.
City beats the race, or?
What?
Because they take, or when does it race? Because they take forever, but they always get it right.
All the following functions satisfy the conditions of MVT except depends on how carefully you're going to go.
I'm going to go really carefully. I don't want to.
Inspirational theme song. Oh, you guys don't have it yet? I have it. It's okay. It's not about who gets it first. You're right.
Oh, that's a really good idea.
If both the leading groups get it wrong, you guys could theoretically all tie. Go carefully. I'm not giving the final answer until the other two groups weigh in. The two leading groups just clocked in with different answers.
Oh dear. Oh dear. No.
In both classes.
No. Our logic makes sense, Hannah. Okay, does it? I'm confident. Does it? Yes, it does. Our logic makes sense. I think we're right. I'm gonna hold on to that hope because I really want.
We have one confident group, one not so confident group. One is right, the other one's wrong. The other two groups are still out. Think through your logic. You might find a mistake in it. Think through your logic. Or maybe you're the right one.
So like it doesn't satisfy the. Oh, I think the detection's on. This is a test of the National Wireless Emergency Alert System. No action is needed.
Wait, what?
I feel like we did.
Mrs. Christensen said there was one coming out today at 11:18, 11:19.
I thought it was going to be Donald Trump. I thought I was going to get a notification like Donald Trump.
Hey losers, what's good?
Losers.
The problem is that it's bothersome.
Oh yeah.
Okay, one more minute. I'm not saying.
I was hoping.
I'm very amused. I'm very amused.
My anxiety is building. I'm gonna cry.
Because the wrong group should be finding their mistake.
How do we know which one's wrong?
No, I'm just saying, like, you both are analyzing. One of you should find a mistake.
Okay. Hannah, let's think about. Our logic works. Our logic is valid. It is a justified true belief. It is knowledge. Epistemology. Mr. Strike.
Dude.
I kind of popped off.
30 seconds.
No, what if we don't have work? Can we just guess?
Yeah. I mean, you should have some sort of justification as to why.
It is a justified true belief. We're good. It's knowledge. Stand your ground. Apologize.
Okay, maybe we didn't. Maybe we didn't do it.
Shoot your shot.
I'm not answering. So far, one of the last groups to check in agreed with one, and the other one agreed with the other. I have 2 Ds and 2 Bs. I have 2 D's and 2 B's. Pause. This should not have been. Shh. There is a mathematical answer for which is which. What's the derivative of sine inverse? I'm doing both. What's the derivative of sine inverse? Both of these. What's the derivative? 1 over the square root of. This is continuous on the closed interval and differentiable on the open interval. He's fine.
I told you!
No, it doesn't have to go to 0.
This one is continuous on the closed interval, but not differentiable at. Woo! Final answer, D. Final winners.
Doesn't sine have an
Final winners.
I know, but it doesn't have to be 0.
However, still high fives. Still high fives. Still high fives.
Wait, Miss Lee, can you explain?
Group number 1 wins with 7 points. Group number 2 ties for second place with 6 points. Ties group number 3 and group number 4. You had 5 points. 7, 6, 5. I'm not too disappointed in that. Erase your boards. Get back to the front because we need to finish up section 5.4. Nope, 5.3.
So confident.
I know you were. I was like, oh, take your derivative.
Doesn't the graph of sine inverse have an asymptote at 0? Okay, I guess I just don't.
Sine inverse is the sine curve. He doesn't have any
Like,
asymptote.
so the sine curve starts at 0, right?
He doesn't work at pi over 2 and past pi over 2 and negative pi. No. Hold on. Sine inverse doesn't work past 1 and negative 1, but he works everywhere in between 1 and negative 1. Yeah. No. It is.
I'm questioning everything I know about math.
This is sine inverse. This is sine inverse. And he's fine in between 1 and negative 1 from negative pi over 2 to pi over 2. Yeah, because he's the sine curve flipped. He's the sine curve inverted.
So what's the one where it touches the tips? Is that?
Secant and cosecant. Whew. So why are we ending with this guy? What was section 5.3? Connecting f with f prime with f double prime. What's this asking for? You to analyze. Analyze what? Analyze this guy. What other example? This one? Oh, it was a ... You're going to have to factor him. I didn't want to factor him. Did you guys want to? Yeah. Yeah, you get the idea. You're going to have to factor out a 2, and then you're going to have to play with testing in to find zeros. Ugh. Yes, that would have probably been wise. If it went in, though, did it go in? We would have had 8 minus 8 and then 2 minus, wouldn't have gone in perfectly. But yeah, you could have dealt with what you had left over, taken the derivative after long division. What do you guys think? Would that have been smarter? Oh, you did that. Look at Hannah go. All right, let's end with this example. This is the last example for section 5.4. Well, kind of. I do have a little page of PS, things you can think about when going between graphs that you guys can check out as you do homework for section 5.3. But we're going to actually end on this example of actually dealing with a graph of the derivative on the interval -4 to 4. If you guys are making the graph, there are points at -2, 0. There are points at -2, 0. At 0-ish 1, it's a little bit to the left. The maximum's a little bit to the left. But we'll say 0, 1, 1, 0, and then 4, 0, with a minimum at 3, negative something. So I'm going to go ahead and attach these real quick just for the sake of the problem. So we're going to attach the maximum to be at 0. We're going to attach the minimum to be at 3 endpoints. Here, here, here. Okay. So, question. Where's f increasing based on this graph of the derivative? Ooh, stop it. -4 to 1?
To 0. No. 1.
We can go from -4. Why am I doing a closed interval at -4 but an open interval at 1? Yeah, at -4, the function is positive, is a positive y value. I should say the derivative. At negative, derivative is positive, hence f is increasing, but at 1, the derivative is 0. Could you have split it up at -2? Yes, you could have. You could have, but an infinitesimally small point in space, they won't really get mad at. You're fine. Where's f concave up? Pause. Don't tell me the answer yet. Pause. Don't tell me the answer yet. Why is f prime increasing? Because why is f increasing? Oh, that was dangerous. Why is f increasing? Because f prime is positive above for all those values. What should I be thinking of for concave up?
Where the derivative of the derivative is positive.
Two different ways of thinking about it. Talking about changes of sign, careful, changes of sign of the derivative. You're thinking points of inflection.
So like if the graph like at 1 goes from positive to negative, so that's a maximum, so that's concave down. So can you just like inverse?
Careful, because on a more complicated graph, there might not be concavity. Does that make sense? Because it could be a instead of a. But technically, Riley is right. But I'm not sure if that would be enough to tell you where to start the concave up and where to stop the concave up. It does tell you around here there should be a concave down. Wait a minute, we're looking for concave up, right? Where's concave up then? See, it doesn't help us with concave up. It helps us with concave down. But Justin's, look at the rate or the slope of the derivative. Can't I think about f double prime on this graph by looking at the slopes? So couldn't I say concave up is going to be when f double prime, aka the slopes, are positive? Or couldn't I also say where f prime is increasing? Same thing. I could either look at where f double prime, the slopes are positive, or where f prime is increasing. That might be easier on our brains. F prime is increasing when the second derivative is positive, which makes the original concave up. When's f prime going up? -2 to 0, and 3 to 4. -2 to 0, and 3 to 4. Do you guys see what I just did? This graph is sloped up from -2 to 0, and it's sloped up from 3 to 4, or f prime is increasing on those intervals. Everywhere else, it's concave down. F is concave down. Riley, you already told us letter C. Who's my local extrema in this graph? Only at x equals 1, and what's there? Good. There's a relative or local max at x equals 1 since f prime changes from positive to negative at that point. I'm not fully writing that nicely, but you guys get the idea. How about letter D? Where are the inflection points?
-2, 0, and 3.
Ooh, why -2, 0, and 3? Justin's totally right. The f double prime is 0, but not enough. F double prime changes signs. The slopes change from positive to negative or negative to positive at that point. Or couldn't you also say, at those points, couldn't you also say that f prime changes from increasing to decreasing? Sorry, decreasing to increasing, or vice versa? Yeah, that would work too. What's the last one? Possible sketch. That's for you guys to figure out. All right, cool kids. Go tackle this homework. 5.3, analyzing graphs of f prime, f double prime, and relating them all together. You guys got it. I'll see you tomorrow. Or maybe I'll see you today. I don't know. Happy Wednesday. Did I get all my whiteboards and markers and tissues back? Well, tissues, no, throw them away. I don't want them back. Never mind.
Thanks, Missy.
You're welcome. Winning group, what treat do you want tomorrow? Cookies, brownies, donuts, fruit?
No, Sally, you can decide. Wait, no.
Tell me by the end of the day.